The search for life outside our planet has been a long and tireless one that has been haunting the greatest minds each and every day. As we try to cope with the uncertainty of its possibility, we've been teased with signs, signals, and glimpses of prospects which could very well mean that there is actually life out there. Our neighboring solar system, Proxima Centauri, and its planet Proxima B have been courted to have the potential for life, observed through its anomalous lights that might just be artificial. We're barely at the tip of the iceberg on this one, but could there actually be a civilization there? Or do we once again not have the answer? The year is 2020 and an international team of scientists has just confirmed a planet the size of Earth around the closest star in our solar system, Proxima Centauri. A report published in the journal Astronomy and Astrophysics recalls the possibility of the planet Proxima B having a mass of just about 1.2 Earths and located in the habitable zone of Proxima Centauri could potentially have life. Like the vast majority of things related to the great beyond, there are always ifs, buts, and maybes lingering behind it. The system's star, Proxima Centauri, is a red dwarf, much smaller and cooler than our Sun. Because of its smaller and cooler stature, the system's habitable zone, or Goldilocks zone, which is neither too hot nor too cold for liquid water to exist, is very close to the star. Proxima B orbits about 20 times closer to its star than Earth does to the Sun. And a year on the planet is just over 11 Earth days long. Let's put that into perspective. If you were 25 years old on Earth, you would be about 830 on Proxima B. That's a little too many birthdays. Anyway, it is believed this planet is likely to be able to support alien life forms. The study suggests that Proxima B is even more like our home planet, at least in size, than previous observations led scientists to think. The first indication of the planet's existence came all the way back in 2013, when Miko Tuomi of the University of Hertfordshire, from archival observational data, conducted research on the planet, continuing his search all the way until 2016. The research team studied Proxima B using the Echelle spectrograph for rocky exoplanet and stable spectroscopic observations, or ESPRESSO for short. Can I just take a moment and appreciate how cool that last abbreviation was? ESPRESSO. Remind me to get some coffee after this. Anyway, ESPRESSO is a Swiss spectrograph that is currently mounted on the European Southern Observatory, or ESO's Very Large Telescope in Chile. For those of you who are unaware, spectrographs observe objects and split the light coming from those objects into the wavelengths that make it up, so researchers can study the object in closer detail. Proxima Centauri is approximately 4.2 light-years from our solar system, but NASA estimates it would take approximately 73,000 years for us to reach the planet, unless new technologies are developed. The detectability of artificial lights on Proxima B has been on the minds of our finest researchers. The planet is a world we can hope to learn a great deal more about with new instruments, and the James Webb Space Telescope is certainly one of these. The use of the JWST is a given, but astronomers also point to LUVOIR, or Large UV Optical IR Surveyor, a multi-wavelength space-based observatory with possible launch in 2035 as an option. Authors Elisa Tabor of Stanford University and Avi Loeb of Harvard point out that a potential tidally locked planet with a permanent night side would need artificial lighting to support a technological culture. Researchers haven't confirmed if Proxima B is a tidally locked planet, but researchers suggest that it is. There are several ways to tell alien technology exists on another planet. For example, we may be able to see the lights of a distant world waver with a massive constellation of satellites. You know, the same stuff that's happening on Earth as well, with the increasing number of satellites that we push out into orbit. While these indications of technology could also be caused by natural phenomena like orbiting debris or a comet's impact, artificial illumination is distinct from the natural light of stars. Tabor and Loeb took the Webb for a virtual alien night hunting test drive last year, but they haven't gotten their hands on the real thing. The results were a bit off. The virtual JWST is trained on Proxima B, the one confirmed planet in the Proxima Centauri system that could presumably host a civilization. Tabor and Loeb scaled artificial illumination as a fraction of the solar illumination reflecting from the day side of the planet. 0% on this scale would assume that the night side of the planet is completely dark. 100% means the night side of the planet is as equally bright as the day side, which also isn't a possibility. The type of light used by the hypothetical civilization on Proxima B is assumed to be similar to LEDs on Earth, which have distinct artificial characteristics. So what have we found out so far? Well, if the artificial night side illumination of Proxima B reaches 5% of the natural day side illumination, the Webb could detect the artificial light with 85% certainty. If artificial illumination were to reach 9%, Webb's detection rate would rise to 95%. 5% illumination might not be a lot. We are talking about the light from a star. As faint as Proxima Centauri is compared to our Sun, which is about 20,000 times dimmer. That's almost like putting a flashlight in from on the Sun, but even that much at a cosmic level is still a lot of light. By comparison, Earth's artificial illumination is only 0.001% of reflected stellar illumination. In other words, if Proxima B hosts a civilization as lit up as us, the Webb wouldn't be able to detect it. Those lights would need to be 500 times brighter. The scenario is plausible. Proxima B orbits so closely to its host star that it may be tidally locked, as we've mentioned before, with one side of the planet always facing the star, while the other is in perpetual night. A civilization on a tidally locked planet would probably need to focus on its lighting infrastructure and could use very bright orbital mirrors to reflect sunlight onto the night side of the planet, which could be seen by our telescopes. But that's of course just a hypothesis. Tabor and Loeb's research indicate that other future telescopes such as LUVOIR or Large UV Optical Infrared Surveyor may even be more capable than JWST at spotting the glow of a distant civilization. Just a few days after the researchers' publication, Thomas Beatty of the Department of Astronomy at the University of Tucson justified that with those numbers. Beatty reviewed both LUVOIR and HABEX, or Habitable Exoplanet Observatory, to understand how these telescopes will detect city lights not only on Proxima B, but also on planets orbiting stars out to a distance of 30 parsecs, or PC. 1 PC is about 3.26 light-years. Both LUVOIR and HABEX have missions to catalogue and directly image exoplanets and are scheduled to launch in 2035. So, there's a long way to go before that. Beatty used virtual LUVOIR and HABEX observatories on several star systems with known worlds like Proxima B, as well as hypothetical Earth-like worlds orbiting G, K, and M-class stars. Beatty also scaled the percentage of the planetary surface which was urbanized. The more urbanization, the brighter the planet's night side. The type of artificial illumination in this model simulates the most common lights on Earth: high-pressure sodium streetlights reflecting off concrete surfaces, which also feature a spectrum distinguishable from natural starlight. So the variables are A. Distance from Earth, B. The planet's level of urbanization, and C. The type of star the planet is orbiting. In each scenario, the virtual scopes are imaging planets for a minimum of 100 hours to collect enough light streaming through the void to resolve the target. Okay, so wait. There's a slim chance that there actually might just be life on Proxima B, according to the previously mentioned research. But how do we get there? Easy. Ionic propulsion, nuclear thermal propulsion, nuclear pulse propulsion, fusion rockets, and laser sails have all been considered as methods to travel to the planet. Simple, right? Well, it's easier said than done. Francesco Pepe, a professor in the astronomy department in the UNIG's Faculty of Science, in a statement said, "We were already very happy with the performance of HARPS, which has been responsible for discovering hundreds of exoplanets over the last 17 years. We're really pleased that Espresso can produce even better measurements, and it's gratifying and just reward for the teamwork lasting nearly 10 years. Proxima B might be about 20 times closer to its star than Earth is to the Sun, but receives comparable amounts of energy. If there is liquid form on the planet, it could harbor life. But researchers said there is still much to be done before that can be confirmed." Alejandro Suarez Mascherano said, "Confirming the existence of Proxima B was an important task, and it's one of the most interesting planets known in the solar neighborhood." Christoph Lovis, a researcher in the University of Geneva's astronomy department, said, "Is there an atmosphere that protects the planet from these deadly rays? And if this atmosphere exists, does it contain the chemical elements that promote the development of life? It is also possible that there could be a second planet orbiting the star, as the research team found evidence of a second signal in the data, but was unable to determine its origins." Professor Pepe said, "If the signal was planetary in origin, this potential other planet accompanying Proxima B would have a mass less than 1/3 of the mass of Earth. It would be then the smallest planet ever measured using the radial velocity method." So, what do you think? Is there life on Proxima B? What more will we be able to find from this research? And with new telescopes like Webb, what else could we find on the planet? Let us know your thoughts in the comments below, and as always, thanks for watching Space Age.